Okay, question 6. We've got a question about some waves, and we can see a massive water tank, ripple tank. You'll remember playing with the little ones in the lab. I think you probably did the practical 2 or 3 times. So what we're going to look at now is water waves. So water waves are transverse waves. So what do we know that means? I'll put T in a circle there. It means the vibration or the oscillation is, oh my God, is perpendicular to the direction of the energy. So V, P, D, O, E, T. That's the energy moving along. All right, and they're at right angles to each other. So it says, given another example of transverse waves. So we could go with, well, light is a transverse wave, or S, secondary seismic waves. Just go with light, that's far easier. So light and water. And then if you want longitudinal waves, we could go with sound, and we could go with P, seismic waves. Okay, next one. Oh, this catches students out all the time. So it tells us a distance here, and it wants us to measure the wavelength. So obviously we just got to count the waves, and then divide that distance by the number of waves. But the crucial part is I've got to wait for me to go a full wavelength. So label the start. Always the peak or the trough or wherever you're on the wave, label that as start first. So I'm going to get rid of all of that because I spent a bit of time tidying this up because of my damn awful writing. So there we go, I've counted them. 10 waves or 10 peaks. And then 32. So 10 waves in 32 meters. Take that distance divided by the waves. They are 3.2 meters each. Nice, easy question, but that is the tricky part. Make sure you label the first one start. As you can imagine, students go 1, 2, 3, and then they end up getting the wrong answer. Okay, next one. A technician stands at the side of the tank. He counts the waves as they pass him. 12 peaks go past in 15 seconds. Calculate the frequency. Now, lots of students will end up doing the foxes stab whales and then go, oh, I can't do it. All it's testing is, do you know that hertz is the number of waves per second? The number of waves per unit time. Well, we've got the number of waves, 12. We've got the time, 15. So we just divide those two. So frequency is the number of waves divided by the time. 12 divided by 15 equals 0.8. But please do not be tricked into doing your foxes stab wolves. You don't need it. All right, it's that basic waves divided by time. The next one, we want to know about seismic waves. It's a longitudinal wave. So energy goes that way, vibration goes that way. So there we go, that's a longitudinal wave. So this must be a seismic P wave. So here's a primary wave. Can go through solids and liquids, and it is faster than an S wave. Draw arrows to show it moves. So we just got to say it's going to go along that line to it. Perfect. And the vibration needs to be parallel to it. Done. I'm going to show it's moving forwards and backwards. It's a vibration. So show it's a vibration, mark. Show it's parallel to the direction of the energy, mark. Next one. Now we do get our foxes stab wolves. So let's get that ready. It says calculate the wavelength. That's that lovely bit here. And it even tells you the formula to use. Equals S over F. So let's have a look at it. So the wave speed is 7 kilometers per second. Nasty question. This needs to be in meters per second, so I'm going to have to times that by 1,000. Equals 7,000 meters per second. You're in hertz though. Happy with you. Big smiles everywhere. So now I've just got to plug that in. So 7,000 is my speed divided by 12 equals 583.33333, 583 meters. Done. The technician measured frequencies of the water waves in part A by counting how many waves passed him in 15 seconds. All right. So explain why this would not be a useful method for measuring the frequency of the seismic waves. So let's go back to the picture. And we can see, well, these are going to be moving relatively slowly with not that many waves passing each unit time. So I can actually count them. This seismic wave's at 12 hertz. It's vibrating 12 times a second. There's no way I'm counting that. Even if you're a Fortnite ninja, you're not counting that. So that's the basic idea. These waves are too frequent to count. That's going to be a mark. So going on to this, the other part is you can't see these seismic waves. They're passing through the ground. You can't see them. You might feel a bit of a tremor, but you're not going to be able to see them. So the first part is you can't see them. I'm going to need a seismometer. I need something to measure seismic waves because I can't see them. You would get the mark for just saying you couldn't see them. They're in the ground. And the next part is, and they're too frequent to accurately count. Done.